Hello, everyone. Welcome back to another Security Shorts with Scott. Thank you for joining us as always. I'm very excited to have Jeremy Snyder, founder and CEO of Firetail, with us today. Jeremy is a longtime expert in security, been in the space for years, and he and I have a common bond is two of the people that, or one of the people I know personally that spend a lot of time overseas. Jeremy, welcome to the podcast. Thanks for coming.
My pleasure, Scott.
Awesome. So everyone, what we're going to talk about today is a topic that actually comes up a lot as far as like just the general way we do infrastructure these days, but think less hardware and more connectivity. And for those who have been around networking engineering a long time, the concepts that we derive from this conversation will be familiar to you. They're just done in a very different way. So we're going to talk about APIs and we'll talk about API security today. So Jeremy, before we get started, we always like to do a little personal intro. How did you sort of get into the space of security and infrastructure and coding, development, and all that?
Yeah, it's been a journey. I actually started my career kind of hands-on keyboard. I thought I would be a software developer. Turns out I wasn't that good at coding. I joined a startup with the intention of being a software developer, and they were like, yeah, you're not quite up to the level, but you know what? We're growing so fast. We need people on the network, IT, infrastructure side. And this is in the days when you're building your own data centers, right? So I rode that for a good 7 years at that company before we got acquired. Also gave me the startup bug. So I've kind of spent most of my career in the startup land. But then I went on to two other companies, another SaaS company, then a video game company, before kind of changing to the other side of the table and into more customer-facing roles. So I spent about half my career as a practitioner in the IT and security domain, and then the other half working, kind of in cloud infrastructure, cloud security, et cetera. And actually, the last part, it was along the cloud security journey. I was on site with let's just call them a very popular music streaming app. And I was on site with their cloud security team, and we were talking about the kind of the home screen when you open the mobile version of their app. And they explained to me that it was 100 API calls just to render that screen. And I just found that mind-boggling. But when I started to kind of dig into it to understand, well, how is that the case? And they're like, well, you have your account information, and then you have your playlist, and then you have what you last listened to, and the recommendations for you, and so on. And they broke it down to me to show me that all of the applications talk to each other over APIs. And I kind of filed that away as we continued that cloud security company for another year and a half before getting acquired. And then when I left the company that acquired us, I went back to that idea and I kind of looked at the state of the market to see if that was a one-off or if that was in fact indicative of how modern architecture was changing. And I did find, sure enough, that this is actually the direction that kind of everything is moving into.
Absolutely. I love the background. I think I last coded on Power Builder or something and realized I was probably better at networking than I was at coding development. I love this story around APIs. So for those who are in the space, there's a meme around that I think Musk talks about all the time, which is APIs will control the world. Why don't you sort of explain what's an API and why are they so important in today's infrastructure and operations?
I mean, look, API stands for Application Programming Interface. And I think the simplest way to think about it is an API is the way that two pieces of software talk to each other. That is the simplest way to think about it. And the word that you used earlier to describe them, connectivity, I think is super relevant because it really is what connects system A to system B. Let's put it into an example that I think a lot of the audience will really resonate with. Mobile food delivery. Every time you pick up an app on your phone, DoorDash, Uber Eats, Delivery Hero, whatever it is, wherever in the world you live, you'll have some mobile food delivery app. Well, I sat with an engineer from one of these companies once, and we started to map out the interactions that happen in that what to you is one transaction, more than 30 API calls just to enable that one thing. And that sounds crazy, but when you start to break it down and map out, you've got, okay, you open the mobile device and you get your geo coordinates from triangulation and you send that to the service. And then it gives you a list of restaurants that are available to you. Boom, there's a set of API calls right there. And then you package up your order and you send that off. Well, most of these companies, again, DoorDash or whoever, they're not processing the payment. They're sending that to a third-party provider, another set of API calls, which, by the way, have your credit card information in them, right? And then I've got another set of API calls out to the restaurant to transmit the order, and another set to confirm that it's ready, and another set of calls to a delivery service, and another set to confirm delivery. And you go through this thing, and this is really indicative of the modern internet. APIs are kind of the connective tissue of the modern internet. All of these services that are enabled by all the bandwidth that we have, by the super rapid computing infrastructure that we have, by the ability to just reach out and build on top of services that already exist to stitch things together, to build applications. That's how the modern internet works, and that's why APIs are so critical.
Love it. I love the analogy because when I talk to people and they're sort of asking about APIs, they tend to think of like a program as a single thing, right? So we think of DoorDash as a program in the same way that
Yep.
Excel or PowerPoint is
Yeah.
a program. And what they don't realize is really there's a million different applications sitting in the background. And
Yep.
the UI obviously is connecting to these million different applications, and they have to connect that way.
Yeah.
And so if you have a legacy understanding, then you immediately start thinking routers and switches and firewalls,
firewalls,
and detection systems, and you start thinking
Yeah.
of all the security we put into the connectivity of the
Yep.
internet. API security has really, in part of the reason why Firetail is doing well. API security has really been a bit of a laggard because posture was really sort of, it's like, is where my storage located, where all my data is that open to the internet or not? So really,
Right.
posture was really a sort of focus for a long time, which is very different than security and detection and
Yeah.
structure. So walk us through sort of where API security is heading.
Yeah, this is such a great point because there's a lot of companies that are trying to approach it from different perspectives. And to your point, it is a little bit of a laggard in the sense that most companies and most organizations are just now, as we record this, getting their first taste of API security or getting their first exposure to some of the risks around APIs. And exactly as you said, a lot of organizations are thinking, well, how can I apply a firewall to this? I'll just block bad actors from accessing my APIs. That's an approach, right? In the age of cloud, I can tell you that that is not really a valid approach anymore. A bad actor can change their IP address at any moment's notice. On top of that, when we actually looked at the history of API breaches and started to break them down and analyze what goes wrong in those situations, the number one, like by far, is an authenticated user abusing their access to gain unauthorized access to data that they shouldn't have access to, right? And so what does that really mean? That means a threat actor finds your API, figures out a way to get a token, and that can be stolen from a cookie, that can be, from malware, that can actually be by just signing up for your service. And then they find a logical flaw in the permission system of your application to gain unauthorized access to data. If you had to say, like, what is the most common pattern that we see across all of these API breaches, that's it by far, right? And the second thing
Jeremy,
about
what
it,
do you call that? Is that misconfiguration? Is that poor authentication, identity access management?
yeah, in the OWASP API top 10, there's 4 things assigned to it, but they're kind of abstract, if you will. They're typically referred to as broken object level authorization or broken function level authorization or broken object property level authorization or excessive data exposure. All of these are to say they're really flaws in the design of the application. That's really the simplest way to think about it. It's something within the permission system of the application is poorly designed. And this is again why a lot of things that live outside the application, things like, let's say, network monitoring systems, they don't have the level of visibility into the application logic to know what's good or bad. And that's why those types of approaches tend to kind of fall short a little bit.
Yep, makes sense. And you were about to say the second thing to sort of be aware of.
Yeah, the second thing to be aware of is, this is not going to come as any great surprise to anybody, but we're now facing the wave of challenges with APIs that we faced with cloud, call it 6-7 years ago. And that is when you go into an organization and you say, well, what APIs are you exposing and what APIs are you consuming? The answer is consistently, don't know. And, when we talked to customers 6-7 years ago, what's your cloud infrastructure look like? I don't know. And that's because, 20, 50, 100 people within the organization have access to push stuff or create stuff and so on. And so we're finding pretty consistently that the biggest challenge around APIs, aside from the business logic question, is just gaining visibility and monitoring over APIs. And it's particularly challenging because APIs can kind of live anywhere. You can run them on-prem, you can consume them from your laptop, you can run them on EC2, Lambda, EKS. I use the AWS examples, but the same is true for all the other cloud providers. And so gaining and maintaining visibility of an API inventory that you can assess and understand where your risk points are, that's a big challenge and a big risk to a lot of organizations. So that was the second thing I was going to say, is just kind of like that overall understanding of what your API footprint and your API posture looks like is really challenging.
It really makes sense if you think about these companies that all of a sudden become super useful. The Ubers, the Lyfts, the food delivery. Like, they're going fast, they're going hard, and keeping organized of all this stuff is really difficult. So one day somebody's like, well, I can't do A, B, and C. And somebody's like, oh, I'll just build a API for that, make sure all the connectivity.
Exactly.
But
yeah.
Do they map that anywhere? Is that tracked anywhere? Is there a master list, obviously, or a tool that shows? So it totally makes sense when you think about people just trying to get the work done, right? It make good on the promises that customers are sort of expecting. So there's a problem with companies with API proliferation relative to making sure that the services are being delivered at speed and at scale. So what do organizations, or what does a person that works inside these organizations, what do they sort of need to think about as the beginning principles when it comes to API security?
Well, start with visibility, right? If you don't know that it's there, you have no clue as to what good and bad is, right? Mm-hmm. The second thing that I would say is focus on analyzing the designs of the APIs, because you're going to learn a lot more and you're going to be able to eliminate risk a lot faster or manage risk a lot faster if you think about assessing the design of an API than if you think about observing traffic over a time period. Mm-hmm. Observing traffic over a time period is beneficial. Don't get me wrong. That's a next step that you should think about. But that's going to take time to build up patterns, to look for anomalies, to kind of understand what the baseline and what looks like quote unquote normal for that API is. Whereas, you can actually take a set of assessment tools against an API much more quickly. And there's all types of automated tool suites for this. There are open source ones, there are commercial ones. Obviously, there are companies like us as well who have offerings in this space as well. And you can actually get visibility onto this within a matter of minutes if you go down this route. This will get you kind of a better understanding about where you might have design flaws in your APIs that are easily exploitable, and then kind of manage and mitigate the risk around that. Those are the starting points that I would recommend to any organization.
It's sort of like the shift left concept for development, but into API security, right? It's like build in the right structure and the right organizational principles into your APIs to start with, test those, and take the extra 5 minutes to test it, make sure your design is sort of done the right way, rather than trying to clean it up, afterwards, right?
Yeah. You're always going to get more bang for your buck out of kind of a proactive approach and out of kind of a design analysis than you will out of a long-term monitoring approach.
Makes sense. Awesome. Well, so Jeremy, I know we're about to wrap up here. Are there any final thoughts when it comes just to API security, things that just people should be aware of that are top of mind on your side?
There are two things that are top of mind on our side. And one of them is that the age of AI is actually about to spark a proliferation of API usage across organizations. How are your organizations going to be consuming all of these third-party AI services and large language models? Unless you're the top enterprises that have the budget, the bandwidth, and the capabilities to run this stuff in-house, you're going to be relying on third-party models. Now is as good a time as any to start thinking about, okay, what are the risks involved in that? What are the APIs that we're exposing, communicating with, et cetera? So that's one. Number two is for anybody who's looking to kind of get started on just understanding what are the risks generally at a more macro and broader level. One thing I'd love to put out there for the audience is that we just published our 2024 State of API Security Report that is freely available on the Firetail website. That's at firetail.io. If you just Google Firetail API Security Report, that'll come up in the top results very easily. That'll give you an analysis of all the history of breaches that we've found, as well as help you understand, for instance, what's the current landscape look like? What are some best practices for getting started? And also, what are some of the most common mistake patterns across, let's say, public APIs that are out on the web? We did an analysis of the Fortune 500. That was really interesting to see what's out there, and also to see what attacks we're seeing from monitoring across our customers' environments, to get some sense of what are the risks. Like, we've seen things that we never expected to see. We've seen threat actors attempting to plant malware on systems via API calls. And we're like, that is crazy. That was something we never expected. We expected a lot of data breach attempts, and we definitely see that. We see a ton of bots for sure. But seeing attempted malware exposures, things like that, that's been really eye-opening for us as well. And that report is free, like I said. So I'd encourage people to check that out.
That's awesome. Jeremy, thanks for joining. I guess everybody can find you obviously at firetail.io or
Yep.
AI.io.
We have both, but .io
okay.
is the main one.
And any other place that they should find you?
Yeah, I mean, look, on LinkedIn, we're pretty active as a company. If you just look for firetail.io, we share all of our research out there. We posted our report as well. All of that stuff can be found easily on LinkedIn as well.
Perfect. Jeremy, thanks for joining. To the audience, as always, thanks for joining another Security Shorts with Scott. Hope you found it useful and informational. And we will see you again on the next podcast. Jeremy, thanks again for joining.
My pleasure. Thanks again.